Alright, we're back. We're ready to go through question 2. Question 2 part A, it gave us a function f of x is equal to x squared plus 2. And it tells us that the function is only valid when x is greater than or equal to 0. And they did us the favor of giving us the graph of f of x. Let's put x values 1, 2, 3, 4, 5. So when x is 1, 1 squared is 1 plus 2 is 3. So right here so is, yep, it's lined up is 3. This is 3. When x is 0, the y value is 2. When x is 2, 2 squared is 4. 4 plus 2 is 6. Right here is 6. When this is 3, 3 squared is 9. 9 plus 2 is 11. 9 plus 2 is 11. So let's put that point here. I'll get the gist of the graph. Alright? Now, the first part of the question says sketch the inverse on the graph. So this is the function f of x. Now we need to sketch the inverse. Now remember, a function is a reflection, an inverse rather, is the reflection of a function in the line y equal to x. So first thing, draw a line y equal to x. And so the inverse is going to be, this is the point 2, 0. So the inverse point is going to be 0, 2. 0, x is 0, y is 2. Now the point right here so is 1, 3. So the inverse point is going to be 3, 1. 3, 1 can be here. This is the point 2, 6. The inverse is the point 6, 2. So we can put 6, 2 somewhere here. I'll get the gist. This is how the inverse is going to be looking. That's f inverse. And to just draw that simple sketch, you'd have gotten 3 marks. Oh, sorry, 2 marks. The part 1 is 2 marks. So to do this is 2 marks. Now the next part says show that the inverse of f is a function. So to show that it is a function, you do what is called a vertical line test. If the vertical line only intersects at one point, it is a function. So to draw your vertical line test, look at this. So to draw our vertical line, we just draw a vertical line, and then we're going to tell them, if you to use this vertical line test, I like to call it VL, using the vertical line test, it only intersects f inverse at one point for all x greater than or equal to 2. And so therefore, f inverse is a function. That's it. That's 2 more marks. So all you're going to do is draw a vertical line and show them so the vertical line only intersects the inverse function at one point. Since it only intersects at one point, then clearly f inverse is a function using the vertical line test. Alright? That's how we tell it is a function. Now notice I said for all points greater than or equal to 2 because before 2, it's not defined. Not now go on before 2. Alright? And that's that. Alright. So the next part says prove that f is 1 to 1. So to prove that f is 1 to 1, if we go back to the sketch, this is f of x, something like this. This is f of x, right? Again, we're going back to our vertical line test. If we go back to the vertical line test, this is our vertical line. The vertical line, so you can tell them this, using vertical line test, it only intersects the function at one point. And so we can conclude, hence, f is 1 to 1. In other words, we can say f is injective. That's how you do it, using the vertical line test. And that will give you 4 marks. Just to draw a vertical line and write this, 4 marks. That's crazy. That's 4 marks. Now, of course, you don't have to do it that way. Alright, so another way that we can do it is not one way. Another way is a lot of people like to solve f of a equal to f of b. Solving f of a equal f of b, you're going to get a squared plus 2 is equal to b squared plus 2. That implies that the 2's cancel. That implies a squared is equal to b squared. But if a squared is equal to b squared, that ends up implying that a squared minus b squared equals 0. We can factorize. We get a minus b times a plus b equals 0. From this you end up get a minus b equals 0, or you get a plus b equals 0. From this you get a equal b, which is good, and you get a is equal to negative b. But a can't equal to negative b. A plus b can't be 0. Let's stop it even from here. A plus b cannot be 0. This is not valid. This is not valid. Now ask, why is this not valid? This is not valid because the function is defined for all x greater than 0. So since x is greater than or equal to 0, when x have a value of a, a is greater than 0 and b is greater than 0. Bigger than 0 plus 0 can't give you 0. Or if it's bigger than 0 and bigger than 0 and add it and get 0. That doesn't make sense, so not valid. So since a end up equal to b, then we get hence f is injective. That's it. I know a lot of persons prefer to do it this way, the calculations way. That's still 4 marks. I prefer the vertical line test. That's it. Alright, so part 2 says determine whether f is onto. Now, I didn't erase my vertical line because I'm going to do using the vertical line test again. Now look at this. Using the vertical line, what we can clearly see is using the vertical line test for all x value bigger than or equal to 0, there is a corresponding y value. Guys, if we use the vertical line test, look, using the vertical line we detect when x is 0, y is 2, when x is 1, y is 5, when x is 2, when x is 1, y is 3, when x is 2, y is 6, when x is 4, y is, and it continue and continue, when x is 10, y is 102, when x is 1000, y is 1000 squared plus 2. So for every x value bigger than or equal to 0, we get a corresponding y value. So using vertical line test, for all x there is a corresponding y value, and so therefore f is surjective. Remember guys, what is surjectivity? Surjectivity is, remember when we usually do this in CXC days, C-sec, you draw the box then and put in the x values like 1, 2, 3, 4, and whenever every x value have a y value, you say it's surjective. So in the case like this, from you start from 0 go straight down, all of them gonna have a y value, and since all the y values are mapped onto, we can therefore say that it is surjective. Alright? So yes, this function is surjective. Therefore, f is surjective. Now I know a lot of us want to do it the other way. So this is 3 marks. This is the or way now. The other way to test for surjectivity is to solve f of a equal to b. Solving f of a equal to b, so solve a squared plus 2 equal to b. And if we transpose for a, what we're going to get is a is equal to b minus 2 square rooted from this. Now look at this. What we need to do now is see if every value for a going to give us, what we're going to do is input values for b and see if we get a result for a. So look at this. Did it tell us if it's real numbers? Let us see. Real numbers. So see it here now. We're going to put in values for b. Now remember, first thing is that x is greater than or equal to 0. So just to jot this down, a is always going to also be greater than or equal to 0. So that's the first thing. We cannot input any value. We can't input any value that's going to make a not be bigger than 0. So look at this now. If we think about a case where, let's say b is 5. If b is 5, 5 minus 2 is 3, a would be the square root of 3. That's fine. Alright, so when b is 5, we know that a would be root 3. So that means our point is root 3 and 5. Okay, good. Let's talk about when b is 2. When b is 2, 2 minus 2 is what? 2 minus 2 is 0, and so we have the point 0, 2. That's fine. Now the only values I can try where this square root is not defined is if you try when b is less than 2. So you'd have to try, like, let's say you try when b is 1. Right? If you try when b is 1, you're going to get the square root of 1 minus 2, which is the square root of negative 1. This is not valid. So when b is 1, right, when the y value is 1, nothing is mapped to that. But at the end of the day, this is what the square root of negative 1, which is not defined, the square root of negative 1, which is not defined, that is not greater than 0. This is less than 0. Square root of a negative number have to be less than. Think about it. Negative 1 less than 0. So if you square root this, it must less than 0 too. Yeah. So this is still less than 0. So it's not defined. This is not defined. So we actually cannot try the case where b is equal to 1. This, we cannot try this case. That case is not valid. So when you state that a is greater than or equal to 2, you have to state that b must also be greater than or equal to 2. If a is greater than 0, b have to be greater than or equal to 2, based on the diagram. See here, this is the point 0, 2. So I have to start from 2 going upwards. So if we start from 2 going upwards, for every b value, there will be a corresponding a value. So from this right here, we can conclude, therefore f is surjective. That's it. F is surjective. Alright, part B wants us to solve this equation. The modulus of x squared minus 4 is equal to 3x minus 2. If this is what we're solving, modulus of x squared minus 4 equal to 3x minus 2. Now, we have to remember the rule of modulus. If mod A is equal to B, then A is equal to minus B or A equal to B. That's a rule that we must remember. If the modulus of A equal to B, then A equal negative A or A equal B. So from this, that implies that x squared minus 4, it can equal to 3x minus 2, or we can write, say, x squared minus 4 is equal to negative of 3x minus 2. Either one is fine. Let's start with this side. If x squared minus 4 equal to 3x minus 2, from this we'll end up get x squared minus 3x. Add 2 to both sides. That become minus 2 equals 0. Or, this is telling us minus 3x come over here become plus 3x. X squared plus 3x. Minus minus 2 is plus 2. Bring that over, it becomes minus 6 equals 0. So these are the two equations we're solving. From the first one, x is going to be equal to minus b, which is 3, plus or minus the square root of b squared minus 4 times a times c divided by 2a. So end up with x is equal to 3 plus or minus 3 squared is 9. 9 minus 4 times 2 is 8. That's the square root of 17 over 2. Or, right here, so we're getting x is equal to minus b plus or minus the square root of b squared minus 4 times a times c divided by 2a. That's what we're getting for the second part. So from the second part, we're getting x equal to minus 3 plus or minus 3 squared is 9. 6 times 4 is 24. 24 plus 9 is 33 over 2. So all the answers then are x equal to 3 plus square root of 17 over 2, 3 minus square root 17 over 2, minus 3 plus the root of 33 over 2, minus 3 minus the root of 33 over 2. Those are what we get. Nice. So that's part B. Those are the 4 answers. So this was really fun. Nothing really to it. Nice. Alright, part C says, given the equation 2x cubed minus x squared plus 3x minus 1 as roots alpha, beta, and gamma, determine the equation whose roots are 1 over alpha, 1 over beta, 1 over gamma. So you have 2x cubed minus x squared plus 3x minus 1 equals 0. So just to write down some information, the roots are alpha, beta, and gamma. Now from our knowledge, we know that alpha plus beta plus gamma is minus b over a. That's minus 1 over a, which is 2. Negative of negative half is half. Now we know alpha beta plus beta gamma plus alpha gamma is c over a, which is 3 over 2. And then alpha times beta times gamma, that is going to be d over a minus d over a. That's minus 1 over 2. That's a half. So now we want the equation whose roots are 1 over alpha, 1 over beta, 1 over gamma. So first thing we can start by finding the sum. 1 over alpha plus 1 over beta plus 1 over gamma. Now we'll go back to prep school days, find the LCM. The LCM is alpha, beta, gamma. Alpha into this leaves beta, gamma, plus beta into this leaves alpha, gamma. Gamma into this leaves alpha, beta. Now that's going to be, this part right here is 3 over 2, and 3 over 2 is divided by alpha, beta, gamma, which is a half. 3 over 2 divided by half is 3 over 2 times 2. 3 over 2 times 2 is 3. That works out to be 3. So the sum is 3. Now the next thing we need to know is the product of the two roots. I like to call it P2. The product of the two roots, which is 1 over alpha times 1 over beta plus 1 over alpha times 1 over gamma plus 1 over beta times 1 over gamma. So we work out these, and so what we're going to end up get is 1 over, which is 1 over alpha beta plus 1 over alpha gamma plus 1 over beta gamma. So we can find the LCM. The LCM is going to be, of course, alpha beta gamma. Alpha beta into this leaves gamma, plus alpha gamma into this leaves beta. Beta gamma into this leaves alpha. Alpha plus beta plus gamma. Alpha plus beta plus gamma is a half, and a half over a half is 1. Finally, we need the product of the three roots. The product of the three roots is equal to 1 over alpha times 1 over beta times 1 over gamma. Let me remove the times symbol. Let me just put bracket. 1 over alpha times 1 over beta times 1 over gamma is 1 over alpha beta gamma, which is 1 over a half. 1 over a half is 1 divided by a half is 1 times 2. 1 times 2, this is 2. So since that is what we end up get, the equation now, so the equation is, remember the equation of a cubic is x cubed minus the sum of the roots times x squared plus the product of the two roots times x minus the product of the three roots equals 0. That's the equation of a cubic. So it's going to be x cubed minus the sum of the roots, which is 3 times x squared, plus the product of the two roots, which is 1, so plus x, minus the product of the three roots, which is 2, so minus 2 equals 0. That's your answer right there. That gives you 8 marks. X cubed minus 3x squared plus x minus 2 equals 0. That's your cubic equation, and you get 8 marks to do nothing. So that takes care of question 2. Stay tuned for module 2, question 3 and 4. Alright, I'm out.